This is challenge number 15. We can have a look. It's very identical to challenge 14. It's almost an extension on top of it. We still have our store information. The second data set, the required assign is already matched up for us. We don't need to worry about it. Then we have the warehouse. So for the warehouse, we're looking for individual item location. So previously we have only single warehouse, the main warehouse, but now we have a multiple warehouse. We want to try to match whatever the closest. For the joins, we don't actually care each. So the idea is we're looking for the total shopping distance available from three different warehouses. So we don't actually care. Yeah, item one, item two, total distance. So probably looking for the item one being in the first store, go to one of the warehouse. Item one in a second store will come from different warehouse. We're looking for the straight line distance between each of those. So let's do some drawing first. Because we only care about item, we don't care about requirement. Is the requirement matched or sent? We don't calculate those. That's from challenge 14. So for us, we only care where the store is and where the item is, and hence also the warehouse is. We can probably drop some field. We're going to do some drawing match the store. That's fine. Everything else, we don't actually care. So for the store, let's just deselect everything. So for that store, we care. Priority, we don't care. City, state, we don't need it. Lat long, location we need. For the right hand side, store is a join common field. Item number we need. That's probably the only field we need. If we look what the join gave us, yeah. For spatial, Alteryx is pretty good, and we can use create point. So you can see on the column header, lat and the long, that's automatically picked up. So for the store location, we can create a lat long. Same idea, we can create lat long for the store, the warehouse location. Lat long fine, to pick up, let's run both. Okay, that's done, and that's done. We should get some centroid. Centroid. Then we're looking for the closest. The closest, we do have a tool called find the nearest. T and U. So T for target, U for universe. The order to do it. So it's personally, I'm not a big fan of the way they named T and U. It's not the most intuitive. First, let's actually go big space. Because the US, we may have a very big location. We're looking for the nearest. What do we need? Latlan we don't need, can be dropped. Latlan can be dropped. Centroid, that's probably let's just rename a bit. We already have store, so let's keep that location store. We don't need to change the name, but it's just probably a good habit to make reading a bit easier. And the nearest rank kilometers direction, we don't care about direction. Ranking is fine because we may have multiple match. We're looking for the closest. So we have two anchors, M for match, U for unmatched. So in this particular case, it's fine. We have no U. Everything has match. Now, because we select as the closest store, let's actually demonstrate a bit. If we go, say, 100, 10, to run the workflow again. The idea behind this thing is match. So you can see we have a less match. It's to try to run for each store. The central located store looking for a 100-kilometer radius to find the closest. So only the X is some kind of the third warehouse at 100 kilometer within. So if some match, anything unmatched goes to the bottom one. If we increase the radius, yes, this. If we go for 1,000, also let's actually see match too. Let's see, learning a bit on the tools as well. In this case, we can see we have multiple rows. Probably this is a good idea. Store Z, item one. So we do have the closest match is the second warehouse. Then first is the second warehouse. The second closest will be third warehouse. So you may have multiple match for one target. It's yeah, that's why I say should be your source target. Maybe a better way to understand it. But still, you can see it's 155. It's not all the stores. Particular, we have some kind of duplications for multiple match. That's why I want a bigger number. Just make sure we're guaranteed to capture a store at least. And that's done. So we have 215. That's good. Every store has the one closest match. Next thing we can do is calculate the distance per item. That's aggregation. Oh, wait, they're looking for total miles. Yeah, straight line miles. So let's change the kilometer to miles as the units. Then we want to aggregate for each item. Let's say, so group up for each item, distance mile, we're looking for the total sum of it. Mhm. Total miles, item one, I think miscalculated something. Let's have a look. What's the store one? Before one, you should have 467 miles for store one. Missing by factor four or something. So what we didn't do right. A group by item one. Total distance. Oh, probably need to assign for. Okay, yeah, I think I probably know what that is. Because when we did the join, we dropped a cent for each item. So it's not just like a item once delivered, but how many item as well. Okay, that's fine. We'll keep the assign as well. Goes to here. We actually need to do a mass formula. Let's call that total miles. Total miles. We're going to sum the total miles. Assign mile. So that amount assigned times the miles, just the miles. Let's call that double. It should flow through. We agree. So rather than sum this, we sum of this instead. Yeah, that looks better number. 467, that seems right. We're looking for total, for example, 471 for number 447. Yes. So that is we can use spatial match to find the closest item. Okay, and thanks for watching.